2, 1.
Hi guys, this is Mrs. Geisler and this is Chapter 2, Part 1 of the screencast. Okay, Chapter 2 is on measurements and calculations. You can find the link to the textbook on Schoology, and it's right here, Measurements and Calculations. And just to review scientific method, that's where it begins first, and you should remember this from Biology and Science 9. Also, the PowerPoint that you'll find on Schoology starts with Chapter 2, Measurements and Calculations. So that's what you should be viewing, and view this screencast again to review the material. So going through scientific method, we're going to be using this throughout the year. As you know, like scientists come up with a question or a problem. That's what starts the scientific method. And through that, you come up with a hypothesis. And this hypothesis, has to be tested. So it can be testable, and you have controls that you remain constant and variables that you change. So for example, if you want to determine if wood burns better in a helium environment versus an oxygen environment, you'll have controls of the same amount of wood, same way you try to light it. And variables is the type of gas that you're trying to burn the wood in. So that's what's changed. And you only change one thing. So you don't want to change the gas that the wood's burning in, and the type of wood. So if you might want to try pine or maple wood or something like that. So you only have one variable, because when you get the results, you can figure out what caused that change by having only one variable that you changed. Because if you change the gas and the type of wood, it could be either the wood or the gas, so you don't know. So, and then models are used after, like if you find a phenomenon, or something's huge or something's really small, like an atom or a compound, you have a model so you can observe it better and help you figure out how it reacts with other things, as in terms of a compound or an atom. A theory is a broad generalization that explains a body of facts or phenomena. And moving down, observing, I'm going kind of fast because we reviewed this before. Observing and collecting data is the first thing. So observing through your senses. And qualitative versus quantitative. So quality is the root word here, and it is a description or how you explain something not using numbers. So you might say the desk is brown, the chair is blue. So that's qualitative data. Quantitative data deals with numbers, so it's numerical. So you would say the desk is 4 feet long. So that is all quantitative. All right, and then getting to the SI system, it's the System International de Units. So instead of saying, well, it's the SI system to abbreviate. The basic units to measure length, we don't use feet, we use meters in science. For mass, we don't use pounds, we use grams. For time is seconds, so that's the same thing with the English version. Temperature, we're going to use Celsius and Kelvin. So I have Kelvin listed there, but we also use Celsius. Mole is a unit to explain how many atoms we have. So atoms are really small. Instead of using a really big number, we use a mole, which is 6.02 times 10 to the 23rd atoms. So that's huge. Ampere is, you'll learn that in physics if you take that, and candela is in physics as well. All right, so here's the SI prefixes, and this is in your textbook, your online textbook. And as we go up the scale, if you have 10 meters, it's going to be 1 decameter. So instead of saying 10 meters, you can say 1 decameter. If you have 100 meters, it's hecto. 1,000, it's kilo. And then they jump to 1,000,000, because we can just skip that. Instead of having like 10 to the 4th, 5th, they just jump by 3s. Just to make less units, is mega, and then 10 to the 9th is giga, and then 10 to the 12th is tera. And going below a meter is smaller than a meter. 1/10 of a meter is 1 decimeter. So you have to have 10 decimeters to make 1 meter. 1/100th of a meter is a centi. So you need 100 centimeters to make 1 meter. And 1/1000th is milli, and milli doesn't mean million, it means 1/1000th. So milli is 1 millimeter. Micro is 1/1,000,000th. So micro, you see that little U with the tail? That is a symbol for micro. And then nano is 10 to the negative ninth. So that's nanometer. They're using that a lot in nanotechnology, having these small little things that they can send into the human body, maybe to like cure cancer. So that's what they're using there, nanotechnology. Pico, 10 to the negative 12th, so it's really, really small. And then 10 to the negative 15 is femtometer. And then 10 to the negative 18 is attometer. So it's really, really, really small. All right, so just to review the unit for density, that's mass over volume. So it's the amount of matter you have in a particular volume. So if you have more matter in a particular volume, then it's going to be really dense. Less matter in volume, it's going to be light and not so dense. So here's a practice problem. A sample of aluminum metal has a mass of 8.4 grams. The volume of the sample is 3.1 centimeters cubed. So to calculate the density, you take the mass. So the units for density can be grams per centimeters cubed, kilograms per meter cubed, just as long as you, in your answer, you put the unit, the correct unit. So we're mostly going to be dealing with grams per centimeters cubed. So we put 8.4 grams on top and 3.1 centimeters cubed on the bottom. So 8.4 divided by 3.1 will give you the density. And that's going to be density grams per centimeter cubed. All right, here's another metric ladder. And this is good because the ladder can show you as you go up, you're going to get a larger unit. As you go down, you're going to get smaller. So it's a good visual to see which way you're going. So the simplest way to move from metric to metric is just move the decimal. And you learned this in Science 9, I know. So if, for example, if you have 2.07 centimeters and you want to find how many millimeters it is, I know they show you right there, but you find centi on the ladder and you move down or up the ladder to where milli is. So we know milli's right here. You just move down 1. You move down and to the right. So you're going to move the decimal point to the right as many spaces as you move. So you moved 1. So here's the decimal point. You just move over to the right 1. So that's why our answer is 20.7. And that's the same. Here, I'll do this left one. 80.6 milli. We're going to centi. So here's milli. We're going to go to the left 1 space. So we're moving the decimal point to the left 1 space. So 80.6 turns into 8.06. So that's how you do it. So if you need to go from milli to like the base unit, which will be just meters, so or grams or liters, whatever you're measuring in, you go 1, 2, 3. That means you move the decimal point to the left 3 spaces. All right, just talking about weight. Weight and mass is a little hard to understand the difference. Weight is in terms of gravity. So when we have pounds, it's the amount of gravity on our bodies that gives us pound, because if we went to the moon, we would weigh less because there's less gravity there. So we use grams to measure. We mass it in chemistry. So you're just going to use the scales to take the mass of a particular item or substance. Volume, amount of space occupied by an object. So it's going to be meters cubed or centimeters cubed. So cubed to the 3rd power will be volume, because that's length times width times height. And then you get a cube. Conversion factors. We will pick this up in the next screencast, but this is when we use fractions to convert from one unit to another. So we have to have a conversion factor. What equals what? And this is the factor. If we're going from quarters to dollars, we have 4 quarters equals $1. And we'll pick it up there in the next screencast.